Hello and welcome to Caterpillars of New England, celebrating spring biodiversity, presented by Sara Burrell of the Caterpillar Lab. The Nashua River Watershed Association is grateful to Freedom's Way Hidden Treasures for supporting this free program. The Caterpillar Lab fosters greater appreciation and care for the complexity and beauty of our local natural history through live caterpillar educational programs, research initiatives, and photography and film projects. They believe that an increased awareness of one's local environment is the foundation on which healthy and responsible attitudes towards the broader natural systems of this world are built. Sara, thank you so much for being with us, and I will hand things over to you.
Thank you so much, and thanks for having me tonight. I'm excited to get to talk to some folks who I think are probably already drinking the Kool-Aid, so to say, although maybe we'll reveal a few new hidden treasures or a few new surprising pieces of information that you may not have experienced before. So again, my name is Sara Burrell. I am an educator at the Caterpillar Lab, and my official title is the Education Coordinator. I've been with the Caterpillar Lab since 2019, and I started as an intern. My background was actually in biology and geology, and I had no real interest in working with insects before working with the Caterpillar Lab. I had gone to Antioch University to pursue a master's in environmental education. And through that, I was looking for, a summer internship, as many of us were. And the Caterpillar Lab kind of came along as something to fill that gap, but not necessarily out of a passion. I think I was looking for something that filled more of a role of environmental education in a way that I could still get outside and still participate with people face to face rather than behind the scenes. And I think what has really stuck with me about the Caterpillar Lab and why I'm here 7 years later is not so much the information or the insects themselves, but the way that people respond to these animals and their stories. I think I've worked with many different environmental education initiatives over the course of my early career, and I've never really seen people respond with the same level of engagement and excitement and lasting power that these animals have. I think we have people come back year after year to both our museum space here in Dublin, now in Dublin, and to our traveling exhibits and programs. And they talk about going out and finding some of these animals. They talk about changing the way that they interact with their landscapes and their planting and the way that they see nature and the way that they go on walks and interact with their local habitats. And I think that's something I'd like you to kind of keep in the back of your mind as I'm speaking tonight and as I'm showing you some of these animals, that this presentation is not just about the information or the animals, not just for you, but also something that you can take and communicate with your community as well, and maybe help open some eyes and some hearts to caterpillars as we go on. So a bit more about the Caterpillar Lab itself. I'm going to skip that. We are an educational nonprofit. Our initiatives primarily center around educational exhibits where we set up caterpillars local to New England on their host plants, and we present a display of what's happening outside, inside, in a way that people can get up close without barriers between themselves and these animals, in a way that sometimes they can physically interact, but they can get as close as they want. They can ask questions of our staff and docents and have more of a casual conversation around these animals, their life cycles, what they're seeing in nature, and maybe why they should practice some conservation behavior around it. This photo is of our old Caterpillar Lab down in Marlborough. We recently moved to a bigger space, which I'm sitting in right now. So please forgive me if it's a little bit odd in here. I'm still figuring out our setup for virtual presentations like this one. We host folks from kindergartens, preschools, all the way up through college classes, professional adults. We've had master naturalists come. We have many garden clubs reach out to us, folks like yourselves who are all interested in these animals in the same way. We do some collecting. We go out mostly every day and find the caterpillars that are local to us in the season that they're in with the plants they're feeding on. And we not only learn their life cycles, but also their habits, their seasons. Maybe some new species pop up here and there or undescribed, new to science. And this is a little photo just to share for those of you who haven't seen one of our programs in the past, really what a Caterpillar Lab exhibit or a program might look like in action, where we have some of these caterpillars on the screen here, as close as people want to get. So today we're going to briefly have some words on the screen. I'm going to start kind of at the basics and build from there. I may take some questions or maybe try to gauge a sense of where you all are most interested in going here in a few minutes. So we're going to start with basics. What is a caterpillar? Why we're talking about caterpillars and insects in general here in New England, and a little bit about the ecology of biodiversity using caterpillars as our model and as our hook. Then I'm going to use our microscope and we're going to switch over and we're going to talk a bit about caterpillars you should know, some highlights from spring, some highlights from the Nashua River watershed specifically that you might be on the lookout for. And then at the very end, we'll talk about some different landscape behaviors, maybe some stewardship, and some of the messages that you might want to take back and share with your community. So to start, we are going to start with a microscope. So I'm going to do a little swap here. Bear with me while I figure this one out. Oh, goodness. I really did have this down to a science in our old building. That's one of the challenges of moving somewhere new, is you always get the benefit of trying to just figure out where things are. All right. So we are going to start with one of my favorite animals and also one of the most common caterpillars that you might get to interact with. So I'm going to give it a moment, and I just want you to watch the screen behind me here. This is happening live underneath our microscope. Here's my hand kind of coming in, obscuring the camera. And as you're watching, I'd like you to make some observations. This is usually what I ask of our kindergarten and preschool classes. What are some of the things you see, maybe something you're wondering about? And as you're watching, I'm going to hold this up to our camera. So we are actually looking at a tiny, tiny caterpillar living inside of this sedge right above my fingertip. This is a sedge leaf miner caterpillar. And this individual is probably about 1/10 of a millimeter thick. So maybe about the thickness of a piece of paper, or maybe about the thickness of several human hairs, feeding inside of this leaf. And right now we're watching it mine through the cells. It's a bit difficult to see on the screen because we've got the cuticle or that waxy surface layer of the leaf covering over it. And we've got the head right up here, this black piece, and that's just moving side to side as the caterpillar is feeding. This caterpillar is one who will chew a hole through the leaf cuticle, crawl out, and go off and finish its life cycle elsewhere. Some leaf miners and other plants may make a cocoon out of the leaf itself. Some drop down to the forest floor during the summer, some overwinter inside their leaves, but all end up becoming tiny, tiny micro moths, some of the very smallest moths that you see flying around your lights at night. This is one of the largest groups of undescribed caterpillars that you might have in your local habitats, and one of the easiest caterpillars to find. When you are going out and you're wandering around, exploring different watershed habitats, maybe you're on a trail that people have recently been doing some trail stewardship on, I want you to take a look the next time you're out at leaves and sedges with little tiny yellow or brown patches in them. Some of them might be linear, like this one, kind of in a long straight line. Some might be like the poplar leaf miners, who leave a maze-like trail inside of their leaves. And all of these caterpillars are unique species. They're all different individuals feeding on different host plants with different predators. There's about 1,000 that have been named and described within New England by actually a Massachusetts naturalist named Charlie Eisman, is kind of the leading local leaf miner expert. There's probably thousands more of these that are completely unknown to science, mostly because no one's taking the time to look. So if you're out there and you're wondering, where are all these insects? Many of them are hidden right in plain sight. When we talk about these caterpillars with some of our younger visitors, I've been going to lots of second grade classes recently, so you hear me use lots of this language. I always like to ask folks to think about why these caterpillars are inside of their leaves. And some of it might be because it's relatively easy to eat inside of your food. If you're swimming around inside of your favorite piece of pizza, for example, then you don't have to worry about going out and wasting energy finding new food, but it's also about predation. So these caterpillars living inside of their leaves are really difficult for other animals to interact with. But even with that, we still see birds like chickadees hunting for them. We still see parasitic wasps and flies finding these caterpillars through the cuticle of the leaf and laying their eggs either near or sometimes even inside of the bodies of the caterpillars and feeding on them that way. Those caterpillars living inside their leaves become a much bigger ecological story, and we'll keep talking about that as we go. This caterpillar behind me is another of my favorites, and another extremely common caterpillar. So we'll hold this friend up to the camera so you can see it a little bit better. This tiny black piece here, that is our caterpillar. Unlike our leaf miner, this caterpillar is feeding externally. Ooh, if I can find it, it might be a little too small. There we go. It's feeding externally. You can just see its head moving around up at the top of the box, at the top of the screen. But it's also built something around itself. This is one of our shelter builders, or in this case, we call it a case bearer, because it's wearing a case, it's bearing a case of its own frass, its own droppings. As it feeds, it takes pieces of its droppings, wraps it around its body with silk, and kind of fits inside this little snail shell, almost like a hermit crab, and carries it around as it grows. Again, this is mostly about predation. So maybe this is camouflage. It's trying to look like a dead leaf, maybe bird droppings, anything that's not caterpillar-like. So things like birds who are extremely excellent visual hunters might not find this caterpillar. Maybe it's providing physical protection against things like wasps and flies trying to carry it away or maybe lay their eggs on or in its body. And just like our leaf miner, this caterpillar also goes off and becomes an adult moth. These are all over the place this time of year. Things like cherry trees, some of our apple trees might have these, hawthorns, anything in the rose family tends to have these pistillate case bearers, just like this one with this long black case. But there are case bearers that feed on things like larch. There are case bearers that feed on, let's see, beech trees pretty commonly. They're a little bit more kind of pale tan. And shelter building is another extremely common way of protecting yourself as a caterpillar. And it also leads to a huge, huge variety of these caterpillars outside. One final tiny caterpillar for you all to meet, who's a little bit more local to you than it is to us up here in New Hampshire. Very similar to our case bearer, this is a bagworm. So if you are someone who grows arborvitae or white cedar or interacts with arborvitae in maybe some of its more naturalized habitats, you may be familiar with these evergreen bagworms. And these are caterpillars who, like the case bearer, make a shelter out of what they're feeding on. In this case, it's the cedar needles, and they'll wrap it around their body using silk. Eventually, this goes off and becomes their cocoon. And these have a slightly more extreme life cycle, which make them more well adapted to urban habitats than they are, in some cases, to wild habitats. So this is one where you may not see it out in a preserve, but you may see it downtown in Boston or Worcester, or I think these in Springfield. And these caterpillars, when they go off and become adults, the males get wings, they get eyes, they get to go fly off and disperse, and they exit their cocoon. The females, however, are what we call larva forms, so they don't develop functional mouths, they don't develop wings. In some species of bagworms, they don't actually develop really heads at all. They're essentially just an abdomen full of eggs. And that lets them stay inside their cocoon, lay their eggs, and then they die inside the cocoon with their eggs. And those eggs get a little extra protection from other predators. Eventually, they do go off and disperse, like some spiders. They balloon, so they'll leave a little trail of silk, catch the wind, and fly off, and maybe populate the next arborvitae down the road. This caterpillar right now is about 2 weeks old. In the next month, it's going to almost quadruple in size until it's about the size of my thumb. And these caterpillars, sorry, I just got a pop-up saying add hand gestures. So that's interesting, Zoom. These caterpillars overwinter as eggs. There are caterpillars that do sort of other surprising overwintering behaviors, and we'll get to talk about a few of those later. All right, so I'm going to keep going through some different types of caterpillars here, and this is all with a purpose. Oh, we'll save that one for later. Normally at this stage, I'd be asking, if we were in person, folks to raise their hands and say what caterpillars they've seen this season. You may be starting to see a wide variety of caterpillars just like this one. So the head is kind of down off towards it's off towards this corner of the screen. I'm not sure what side that is for you. And the tail is kind of pointing up towards the top. This individual is one of our fruit worms, sort of the classic green tube caterpillar. And it's one of our favorites because it has a pyramid-shaped rear end, so we get to call it pyramid butts, and everybody always loves when we get to make a pyramid butt joke. This caterpillar is out actively feeding on many of our different leaves. It's a really broad generalist, so it shows up a little bit later in the spring after things like cherry and apple have already bloomed and gotten their semi-mature leaves, just as things like oak and beech are really starting to bud out. They end up becoming a slightly larger caterpillar, maybe about the size of, say, an inch long. And they're pretty generic. They are green, they eat a wide variety of leaves, and they go off and become an adult moth. These are extra special because they are one of our noctuids, or our armyworms or fruit worms. And armyworms and fruit worms, the noctuids, are one of our largest groups of caterpillars. There's, I think, about 60,000 or 70,000 species worldwide. And a huge, huge number of these, the majority, have feeding mouthparts as adults. That could mean that the majority of them are pollinators, but really there's not a lot of great research talking about whether or not they do pollinate and how well they pollinate if they do. I would assume if they're going off and drinking nectar from flowers that they are providing that service. But the more important service they're providing right now, their timing lines up almost identically with the migration of our songbirds. So if you're outside and you're seeing songbirds kind of flitting around through trees, all of our warblers coming back from down south, and they're all starting to nest and raise their chicks in their nests, those songbirds are feeding a huge, huge number of these caterpillars to their chicks. This is one of the more important groups. It's a spring wave of caterpillars, as we call it here at the Caterpillar Lab. And they're taking all of this leaf energy, all of these really tough to eat oak leaves and beech leaves, or toxic cherry leaves full of cyanide, and they're converting it back into a form that other animals have access to, which in this case is the body of a caterpillar. So there's a tension there for people like us at the Caterpillar Lab, where we do love to see these animals. Oh, bye, friend. We'd love to see these animals. We'd love to learn their stories, but we also have to understand that their stories are connected to a bigger ecology, and that they tell a story of sustainability within an ecosystem through both their life as an individual and the services they provide through their death or through consumption from other individuals. So here's another close-up view of this caterpillar. This is another very small one, maybe too small to see on my camera. So we're going to move on to some slightly easier to see caterpillars. Speaking of noctuids, or the armyworms or fruit worms, in this box with our blueberry is a relatively rare caterpillar called the blueberry dart. And this caterpillar is specific to heath habitats. So if you're out walking through a blueberry field, maybe through an understory, oh, we're much bigger than our last one, or maybe you're in a bog, maybe you're out on kind of a heathy side of a river somewhere, these caterpillars could potentially be all over our blueberries, maybe huckleberries, deerberry if you have it nearby. And they mostly are a nocturnal caterpillar. So their camouflage is a little bit less green leaf and a little bit more kind of brown twig, although they're not perfect twig mimics. We'll get to meet a few of those here in a minute. This caterpillar is a bit rare just because of where we tend to find it here in New Hampshire. I think this one is more of a bog specialist for us, although I don't know that we've done a lot of searching through higher heathlands, so it may be more common than we assume it is. Like our pyramid butt or our copper underwing, this is another moth with feeding mouthparts who could go off and become a pollinator. It's also feeding tons of our birds. The moths are feeding some of our insectivorous birds like our flycatchers. This has a very full life cycle. While we've got this one up on the screen here, this is a really good opportunity to try and zoom in on some of the anatomy of a caterpillar. So when we talk about caterpillars in general, There are so many diverse different ways to be a caterpillar. You can be a shelter builder, you can be camouflaged, you can be eating specific plants, you can be eating a huge variety of plants. You might be like this fuzzy caterpillar in this box, covered in itchy, irritating hairs. And there are some unifying characteristics, some things that all caterpillars share, but there's one very important characteristic that we'll get to. Oh, gosh, you were staying so well. Well, on this caterpillar right now, we're looking at its head. Ah, that is the challenge of live animals, is they never quite perform the way you want them to. So those little black dots right at the top of the head, those are the caterpillar's eyes. And caterpillars have 12 eyes, or simple eye spots, a little bit different than our adult moths who have those big compound eyes. Caterpillars are mostly sensing the world through their antenna. So you might notice these little kind of wiggly gold lines up at the top of the head or up by the mouth parts, so really at the bottom of the face. And they are mostly navigating through chemical senses, something that we might consider taste or smell. And those chemical senses are extremely well adapted to these caterpillars finding their host plants. Okay, we are going to choose a less active caterpillar. Here we go. And that is a caterpillar's tail, too camouflaged. Perfect. So our eyes are this little semicircle right down here. We've got the antenna, we've got the mouth parts coming in the middle. Might be a bit overexposed on your end. And all of those senses are adapted to specific or generalist food plants. Some caterpillars do really interesting things where they might feed on a very narrow range of plants that aren't closely related to each other. So an example of that might be something feeding on elm trees and also, let's say, cherry trees. So there might be some shared characteristic between those two plants, some shared chemistry, or maybe some shared seasonality that the caterpillars are keying in on, either through chemical senses like their antennas, or through just the caterpillar's seasonality that we're not quite privy to. This caterpillar that we're looking at on the screen here is a little bit different. This is not one of our noctuids anymore. This is an arebid. And I tend to get in a little bit of trouble for saying this, but I think arebids are sort of the trash can group of caterpillars. It's the group that all of the taxonomists said, wow, these don't fit with anything else. Well, just put them in the arebids. So if you really want to get into taxonomy and lumpers and splitters, this is the ultimate lumper group. This caterpillar is related to a number of our very early spring caterpillars, things like the underwings or some of the loopers. These are long caterpillars with 6 true legs in the front, like all caterpillars. But you can identify an arebid often because of their strange their strange pro legs in the back. So this caterpillar there's 2 pro legs. On the other side, there's 2 more. And then in the very back, they'll have 1 more set of pro legs hanging on. So this has a kind of a unique 6 pro leg arrangement. This caterpillar is also a specialist on vetch, which is a bean or Fabaceae. And notoriously, Fabaceae is a pretty toxic group of plants. Many of the things that eat things in the Fabaceae family, especially things like vetch or down in the tropics, there's a huge number of things like mimosas and tamarind that to us have these really strong kind of maybe spicy or sour flavors. And all of those flavors are anti-herbivory chemicals. So all of the chemistry of these relatively toxic plants are all about stopping other things from eating them. This caterpillar, like many of our other specialists, has figured out over time, has adapted to all of these different toxins and learned to either tolerate them, or I shouldn't say learned, has adapted to tolerate them, or in some cases, has actually been able to take those toxic anti-herbivory chemicals into their own body, create their own set of poisons, and use that as a defense against their predators. So moving past our camouflaged caterpillars, past our early spring feeders, past some of these really odd caterpillars, we have one of our favorite groups here at the Caterpillar Lab. You may be seeing a huge number of these outside right now. feel free to raise your hand in the chat if you have seen a tent caterpillar mass like this. And often, especially in New England, tent caterpillars tend to get a pretty negative reputation. I have my own personal view of why they might be looked so poorly. I grew up out west, and out west we have the western tent caterpillar, who have a really similar life cycle to our eastern tent caterpillars. They show up in the early spring. They eat some of our things like chokecherry out there. But where I grew up, we don't really have the same kind of economic presence of apples or fruit orchards. We are a pretty arid climate, and it's more about ranching and rather than growing apples. And tent caterpillars here in the east, the eastern tent caterpillar, their favorite food is wild black cherry, but apples are pretty closely related to cherries. And it turns out tent caterpillars also love apple trees. And I think some of our negative reactions toward tent caterpillars often tend to be this agricultural association. We see them eating the same foods that we are eating. And because of that, we assume that they must be a pest or they must be something that's directly competing with us for food. Out west, you see a tent caterpillar and everyone says, oh, that's a mass of caterpillars in a tree. Maybe it's a little weird for some folks, but it doesn't have the immediate, oh my goodness, we have to get rid of that. That must be dangerous to our ecosystems. Also here in New England, we have another somewhat similar looking species at a glance, the spongy moth, which is a invasive species that was brought over in the 1800s. And that's that one that created all of that devastation about, say, 40 years ago. We had a mass outbreak in the 80s, and the spongy moths were defoliating our oak trees across the Northeast. They had another resurgence in the last couple of years. So if you drove way up north here in New Hampshire, you'd see tons and tons of oak trees being stripped. Those are similar to the tent caterpillars in some ways. They're hairy. They are full of different toxins that they're picking up from the plants they're eating. Those caterpillars are actually making irritating hairs and an irritating oil on their bodies as their primary defense, whereas tent caterpillars are a bit different. And in their native habitat, things like spongy moths are as important to their ecosystem as tent caterpillars are. However, as soon as they get out of that balance, that's where we start to see more of kind of a mismatch between their context and their wild context and the context they're currently in. And that's how we get our invasive species, as many of you likely already know. The tent caterpillar is a bit different. So a tent caterpillar is absolutely a defoliator. In certain years, when we have a tent caterpillar population boom, we will see black cherries and maybe apples and other related rosaceae plants be stripped of their leaves pretty early in the spring. And these caterpillars can go wild. You might see hundreds of tents in a certain year. You might see trees looking barren. And then the tent caterpillars disappear. Maybe some of those trees that were a little bit weaker, maybe they were sick, stressed for light, or maybe they were competing for resources with other trees nearby. Maybe some of those trees can't tolerate a season of defoliation and they die and clear out. Most of those trees that are healthy, mature, well-established trees can survive a year or two of defoliation like this. If they're an apple tree, they might not produce as much fruit after they're putting in all of that energy back to leafing out. But for a healthy tree, this defoliation is actually a pretty important service that these caterpillars are providing. The caterpillars themselves are going in, they're stripping the trees, taking all of that nutrients, and they're putting it into their droppings, their frass, which in some cases has been shown to help nutrient cycling in the forest floor. So they're kind of pre-digesting some of these leaves for our detritivores, and they might be creating almost like a little compost of their own. Beside that, they are also taking all that into their bodies and creating a more nutrient-rich source for other animals, like our cuckoos, who are stripping tent caterpillar nests open this time of year and consuming the tent caterpillars. You might have things like, is it veeries that also love tent caterpillars that we've been seeing here in southern New Hampshire? We've been seeing tons of tent caterpillar nests get picked open when they're really small, and we think that's happening because of veeries. Or at least that's what we've been talking about here at the Caterpillar Lab. And tent caterpillars are sort of an outbreak caterpillar. So you'll have a year or two of defoliation. They might strip some of these trees, give back some food that season, and maybe they're clearing out some of these younger, weaker trees or sick trees that have passed their prime, and they're creating more space in our forest for things like black cherries to kind of grow back up and maybe reestablish. after a year or two of a tent caterpillar season, we're probably not going to see tent caterpillars for maybe another 5, 10, 15 years, depending on what their predators are doing. Tent caterpillars are eaten by a number of birds, but their primary predators are other insects, things like wasps and flies that act as parasites inside of their bodies. And there are dozens, if not hundreds, of different parasitic wasps and flies using tent caterpillars actively right now, kind of matching their population boom. So as soon as we have a spike in things like tent caterpillars and we get that defoliation season, then we have a matching spike in our parasitic wasps. And hopefully, within a couple of years, that spike takes down that population, and maybe the parasitic wasps run out of food. And then we have the tent caterpillars kind of slowly building back up in the background. And then maybe 5 or 10 years, something happens. Maybe it's a really good year for cherry trees, and the tent caterpillars finally outpace their predators and pop back up. So we kind of get this wobble back and forth. And that's really what stability looks like in a healthy ecosystem. And I talk about this because we are seeing a huge burst in tent caterpillars this year in particular. So I love to kind of try and remind people that that's actually a really good thing. We're seeing healthy forests doing what we want them to do. These caterpillars are also slightly toxic. So we're kind of circling back around to our conversation about the vetch caterpillar and caterpillars picking up those toxins from their plants. They are eating black cherry primarily. And I actually had a second grade class last week tell me we have a second grade in kind of the Boston area that raises tent caterpillars each year as their class project. And this year, one of the classes was very excited to test some different plants with their tent caterpillars. I was feeding them crabapple because I know that's easier for the teachers to identify around their school. So when I brought them, I tagged a bunch of crabapples around the schoolyard. The teachers were feeding them, and I found one black cherry. And there was one class that wanted to switch their caterpillars from the crabapple to black cherry. And they were so excited when we went in and did our class visit to tell me that the caterpillars refused apple, and they immediately moved over to their black cherry, ate all of it they could find, and won't switch back over to apple trees. And that's actually really important. Apples have slightly less of these cyanogenic compounds that can make cyanide inside of a caterpillar's body. And black cherry is full of cyanogenic compounds, which for most other insects are pretty tough to eat. But there's a huge, huge variety of caterpillars that have figured out how to take all of those toxins, put it into their bodies, and like the tent caterpillars, create a really, really nasty internal chemistry that other animals like our birds and some of our other insects might not be able to tolerate. So all of this bright blue that you're seeing on the screen behind me, that's a warning coloration that these caterpillars are using to say, hey, I'm full of cyanide. You probably shouldn't eat me. Of course, then we get things like our yellow-billed cuckoos that can tolerate not only the cyanide, but also all of these hairs all over the caterpillar's body. And those birds, wow, yeah, that's really just not going to focus. There we go. Those birds are able to actually regrow a lining on their throats. So they can eat these caterpillars, get full of these toxic compounds, get covered in all of these irritating hairs, and they vomit up their own throat, regrow it, and go on and eat hundreds more caterpillars. So that's sort of the diversity plus why we like to talk caterpillars all in one. And for every caterpillar, all of our irritating, itchy-haired caterpillars like this one, all of our camouflaged caterpillars, they all share one very important characteristic. They all eventually go off and become adult moths or butterflies. Unfortunately, I was hoping to have a Cecropia moth here to kind of share this message, but our Cecropia moths at the moment are not in the best shape. A lot of our moths, especially the big exciting ones like our Cecropia moths and our Luna moths, have relatively short lifespans, especially compared to their caterpillars. For some of our moths, like our noctuids, they might feed, or maybe like our butterflies, they feed, they live for a long time, they go off and pollinate flowers, they might live for a few weeks laying eggs here and there. Things like our Cecropia moths and our Luna moths and our bagworms, those don't actually feed as adults. Instead, they reproduce as quickly as possible. Maybe they get to lay a few more eggs in exchange for a reduction in mouth parts. And that gives them a little bit of competitive advantage in some ways, but then maybe they don't get to disperse as well. It turns out there's no real winner, whether you're a moth that feeds and lives a little bit longer or a moth that doesn't feed and lives a shorter life. seems like there's about 50% of moths do either one. So just two different ways of living. But all that to say, our Cecropia moths at the moment are at the end of their lifespan with us this spring. We hopefully will have a few more wild ones popping up pretty soon. This year has been a very interesting year, and I am going to talk about our spring here in just a moment, but I want to make sure I don't get too scattered. So I'm going to check our time. All right, we're doing okay. All right. So when we are out looking at all of our different caterpillars, we know that these are all becoming different moths and butterflies. And that really is all there is to be a caterpillar. You can be somebody who looks like a caterpillar, like this individual. Go. This is one of our sawflies, and it looks like a caterpillar. It has many of the same body parts. It has simple eyes. It has mouth parts that move the same way. It has true legs. It even has pro legs that help it climb. And it fills the same niche as caterpillars do. It's an herbivore. It's taking all of this plant material and turning it back into a more available resource for other insects, other birds, sometimes mammals. But this is not actually a caterpillar. This becomes a type of wasp called a sawfly. And in some ways, if it looks like a caterpillar and acts like a caterpillar, it kind of is a caterpillar. But caterpillar is more than a colloquial term. It is the name of a moth or butterfly larva. And for every caterpillar, they get to go through metamorphosis. So I'm going to show you a few life stages here while we have the time. Oh, okay, I was not expecting this, so that's really exciting. Right about now is the season where we start to see a huge boom in caterpillar activity outside. There have been caterpillars overwintering all year. So there are caterpillars like our inchworms that are active throughout the winter. There are caterpillars that are active in the spring that have a second generation in the fall. There are moths active in the winter. There are moths active now. It just kind of depends on what species you're looking at. But as soon as we get this first spring warm up, that's when we see the highest diversity of caterpillars start to show up outside. So we're kind of in the peak of the spring wave right now. We're expecting with this warm up next week into the 70s and 80s, depending on where you're at. We're probably going to get a lot of what's happening on the screen behind me. So forgive my shaky hands. These are nododontid caterpillars or leaf edge mimics. So as they get older, these caterpillars are going to sit on the edge of a leaf, chew through, and look like dead or dying pieces of leaves to confuse their predators. And right behind that little caterpillar is a caterpillar egg. So these are just starting to hatch. These were moths that were very early spring moths. Some of them might have overwintered as adult moths, waiting to be the very first to lay their eggs on our very early season plants that are just starting to bud out. And all of those eggs are just starting to hatch as soon as these leaves get a little bit fuller and maybe a little bit less toxic or less sticky as they mature out of their spring season. Things like toxins and sticky leaves or really hairy young leaves tend to be an anti-herbivory strategy that plants might use as a way to avoid this spring wave of caterpillars. Things like oak trees are really good at avoiding our spring wave of caterpillars. They kind of time themselves a little bit later in the season. It's a lot of anthropomorphizing I'm doing, but that's okay. The oak trees end up being a little bit later in the season to leaf out, and maybe that's when we start to see things like our nododontids with these really large heads and really strong mandibles that are able to chew through those tougher leaves later on. So every caterpillar starts life as an egg, maybe laid by an overwintering moth, maybe laid by a moth who overwintered as a caterpillar and went through metamorphosis early in the spring. And each one of those eggs will develop into a larva, a caterpillar, and eventually those will all go off and become one of the more important stages of metamorphosis. And one of the reasons that our insects with complete metamorphosis are some of the most successful organisms on Earth. So this is a little bit hard to see on the camera here. This is the chrysalis of one of our first spring butterflies. So if you're outside on a warm day in, let's say, February or March or April, you might see a little brown butterfly flying around that looks a little like a leaf. And that butterfly might have been a question mark or a comma butterfly. And those are spending the winter underneath the leaf litter, especially in habitats that are undisturbed. So if you are mowing leaves in a suburban or an urban habitat, if you're raking a lot of these things and disturbing this leaf litter, all of these little tiny moths and butterflies that are spending the winter insulated inside of these little cavities between the leaves or maybe in rotting wood, those aren't going to have that same spot to stay safe throughout the winter. So these would have been out maybe March or April this year. Maybe they started flying even as late as May with how cold things have been. As soon as they started flying, they started mating and laying eggs. And these are our butterflies who feed on some of our earliest spring plants, things like stinging nettle and elm trees, which leaf out really, really early in the season. And that might be why, over time, they've adapted to overwinter as adult butterflies, because they're kind of matching that phenology. They're timing themselves to match their host plants. And maybe their host plants start to bloom a little bit earlier in the season. And we kind of get this match going on over time. So this chrysalis started as a little spiky caterpillar feeding on stinging nettle. They're shelter builders. They kind of tie a leaf over and make a little, almost like a little pyramid out of the leaves. So if you're out and you have a patch of stinging nettle or elm trees, definitely go outside and look for these. Stinging nettle, both the European stinging nettle and the is it the narrow-leaved nettle is the North American variety. Both of those can be really common around trail sides. So if you do have a good trail that's undergoing restoration, or maybe like an old field that's being turned back into habitat, this might be a really good spot for things like our question marks and our commas. Either right now or in a few weeks, depending on what your season is looking like around you, you might start to see these little shiny chrysalis sitting out in the open. And chrysalis are a little bit special. Every single caterpillar goes through complete metamorphosis. They all become a pupa. And a pupa is that middle stage between caterpillar and adult. It's a living insect. It has an exoskeleton. It has a movable tail, which is this part down here, the abdomen. They're breathing, their heart is beating, their body parts just are kind of fused together, almost like they're inside of a cast, or maybe, I guess, have a cast around them that helps shape all of these body parts as they're growing. So right now, this is a living insect. And if we look closely, we can start to see some of its body parts. We have things like the eye, the antenna. We have the wings are actually on the bottom here. This is going to become one of the wing buds. Oops. And all of these little shiny spots on the back are really what make a chrysalis special and why we give them a distinction from other pupa. So most pupa are camouflaged. They are maybe hidden underground, or they might be like a cecropia moth hidden inside of a really dense cocoon to spend the winter. A chrysalis is a bit different. They are pupa that are external and they're obvious to their predators. So somebody like a question mark or a comma is sitting right out on a leaf or a stick, and they're a little bit more camouflaged than other pupa are. They might have leaf-like patterns. Some of them might have these little shiny iridescent spots that might mimic dewdrops on a leaf or look like light filtering through holes in a leaf. Anything that kind of breaks up their bodies, they stop looking like a living animal. Because while we don't always know that these are alive and not just a shell with someone inside, many other animals do specifically hunt for chrysalis and pupa because they are probably the easiest life stage to eat, and they're full of things like fat and protein, these really rich nutrient resources that other animals are hunting for. We've had an outbreak of flying squirrels in the past that have gotten into our little pupa stash here at the Caterpillar Lab and eaten all of our pupa. Specifically, we had one year where the flying squirrels really got to the cecropia moths. And that was a little sad for us, but it also means that there's a mammal out there that knows that pupa are going to get them through the end of winter. On this chrysalis, you can also see one of the most obvious body parts that let you know this is a living animal. I'm going to try and zoom in so you can see it on your screens. So these little black dots on the abdomen of this chrysalis or this pupa, those are the spiracles or the breathing holes. And that is actually allowing air to pass in and out of the body like a vent. They're connected to all these tracheal tubes that send air down into the center of the body. So its respiratory system, its nervous system, parts of its digestive system, these things are all maintained through its pupa or its chrysalis stage. And they break down bit by bit and are rebuilt bit by bit, but it's never dissolving completely and rebuilding like sometimes we talk about. This really is a slow change, faster than we might change over time, but it's a little bit more magical in some ways, I think, than we might talk about it when we talk about, oh, it melts down into goo and we have no idea how it works. It doesn't really do that. It's a little bit more special than that in some ways. And complete metamorphosis like this is extremely important for the ecology of these animals. It allows something like a caterpillar to live in one niche, to eat one plant, have one set of predators, to have one season that it interacts with. And then when it becomes a pupa, it gets the chance to completely reorganize its body. So while it's a slow process, it can completely change color. It can change the plants that it eats as an adult. It can change the habitats that it lives in. It can change the season that it lives in, and allows it to exploit two different niches over time. And maybe that allows the adult a little bit of advantage in how it gets to lay its eggs or how many eggs it gets to lay. Or maybe there's a predator that learns that this specific caterpillar is food. And if the adult looks very different or tastes very different or lives in a very different season, then that adult gets to escape that predator. Of course, there's new predators now that go after these specific adults and have learned over time or adapted over time to these specific characteristics. So you might have a bird, for example, that, like a vireo we observed one year, knows that certain caterpillars have false eye spots to try and look like snakes to scare off birds. And that particular vireo somehow learned that eye spots mean caterpillar and would only take caterpillars with eye spots back to its nest while we were observing it. Well, I should say the film folks that we were working with observed it. That vireo probably didn't know that those moths and butterflies turned into adults without eye spots. So those adults didn't get eaten by that vireo. Maybe. It might have been a very smart vireo. All right. And unfortunately, I didn't bring any moths over here, so we're going to switch back to my screen and my slides to show you a few moths. All right. So while I'm doing that, I do have a couple of caterpillars that I'd like to show underneath the microscope, or at least up close to the camera. So this is a caterpillar you all may be familiar with. This is our tobacco hornworm caterpillar. So this is one that feeds on tomatoes, tobacco, any nightshades. Gosh, this camera. There we go. And in the wild, originally, these caterpillars may have fed specifically on wild nightshades, things like our climbing nightshades, or maybe the black nightshade. All right. Let's exit that presentation. Oh, well, here's our swallowtail butterflies, in case you were wondering what those might look like. And our tobacco hornworms probably historically were a little bit less common than they are now. Because we plant a lot of the same food plants, we like a lot of these same chemicals that are meant to stop things like caterpillars from eating them. But things like our tobacco hornworms have figured out over time how to use those chemicals as their own defenses. And that creates a really tasty food source for us. So in some ways, we've kind of created our own, maybe a garden pest, depending on who you ask, or our own garden competition. These caterpillars are a native species. They are one of our largest, best pollinators in the area. They have about a 4-inch long tongue or proboscis they use to pollinate huge, long nectar-spurred flowers, things that are kind of trumpet-shaped or tube-shaped. These are extremely nocturnal moths. Extremely nocturnal is an interesting turn of phrase. They tend to fly fairly late at night, and so a lot of these are pollinating and sipping nectar from nocturnal, night-blooming flowers. Our sphinx moths in general are relatively economically important in kind of a way that people might not expect. Sphinx moths typically across the world pollinate really fragrant flowers, things like jasmines. Orchids are notoriously pollinated by a number of sphinx moths across the globe, but including here in New England, there are certain orchids that have a relationship with sphinx moths, like our gallium sphinx, I think is a pollinator of fringed orchids. although that might be a little bit more towards the prairies now that I'm thinking about it. But all of those flowers are producing these scents and the long nectar spurs specifically as a way to draw in things like our sphinx moths. And those scents have become extremely important in perfumery, in the smells that we use in our hand soaps, in the world around us, not only in just the foods that we're eating, but also kind of the world that we're creating. And I think it's a bit of a tragedy. I think that people tend to either overlook these moths because they're camouflaged and they're awake late at night and they might be hard to find, or because they're feeding in competition with us in our gardens and our habitats. This is one that can show up in wild habitats, but it's another caterpillar and another moth that I like to highlight because it can both show up in more wild habitats and more kind of cultivated habitats, maybe kind of bridging that gap between what really is wild and what do we consider nature. Another moth that we love is the Polyphemus moth. So this is related to our Cecropia moth or to our Luna moths. And they start life as a relatively large green caterpillar. This is a highlight for us at the moment. You may or may not be able to see this. This is pretty small and green. They are a highlight for us at the moment because these moths are just about to start flying outside in the wild. They are very broad generalist as caterpillars, but one of their favorite foods are oak trees, specifically red oaks. We tend to find a lot of Polyphemus on up here in New Hampshire. Down a little bit further in Massachusetts, you might see them on a wider range, especially if you have things like scrub oak or more white oaks than we do up here. You might get Polyphemus feeding on a number of different plants. So these moths spent the winter overwintering inside of their cocoons, down in the leaf litter on the forest floor, at least here in New England. A little bit further south, they actually tie a little bit of silk on their trees and they stay put on the tree because maybe the difference in insulating layer of snow in the winter, it's not really clear why they have this behavioral difference, whether that's actually a population genetics difference or if it's just a response to different habitats. These moths get about the size of one of my hands if you haven't seen them before, and they make excellent ambassador moths. So they're pretty large caterpillars. They're relatively easy to find if you go out at night with a black light. And if you are someone who leads a lot of walks, or you're just someone who gets really excited about caterpillars and adding those to kind of your life list, maybe you use iNaturalist, they can be really great caterpillars in the midsummer to go out and find. They tend to live in a diversity of habitats. I find them a lot on trail sides. They're one of the few caterpillars that I personally actually can find. And maybe that's because I know the trick of going out with a black light. All right. So one final moth photo before we go back to our microscope and maybe take a few questions. This is I think one of our champion moths, and their caterpillars are actually active right now this time of year. This moth is a Virginia tenuta moth, and it is one of our best pollinators here in New England and probably across the country. They are a somewhat diurnal moth, so you might see them during the daytime. You might also see them at night. They have this bright coloration because they're mimicking wasps. So they're not just trying to scare off predators, they're trying to look like something that can sting or maybe can feed on other insects and stop them from eating this adult moth. Or maybe that's enough to scare off a bird who has learned to associate these colors with a sting. They have a little proboscis tucked up underneath their mouth. And if you want to see these moths, as soon as the goldenrod starts blooming outside, maybe along kind of more open habitat, go outside right at dusk and shine a flashlight across the tops of goldenrod. And you might see these moths flitting around, sipping nectar, along with hundreds of other species of moths that are off living their best lives, pollinating, interacting, living a life that we know very little about. So I'm going to switch back to our microscope view. It would help if I know where the cord is. And while I'm doing this, think of some questions that maybe you would like answered, or something that maybe I said that was a little confusing. And you can start entering those questions into the chat. Oh, great. So this is our Virginia tenuta caterpillar. And they are a caterpillar that, like our woolly bears, like our giant leopard moths, like many of our fuzzy caterpillars, overwinter as a half-grown caterpillar. These are, if you've ever heard someone say no mow May, these are part of why you might want to participate in something like no mow May. Or if you are practicing trail management, why you might think about kind of edge habitats on the sides of trails and what that habitat is really providing for. These are caterpillars that feed primarily on grass. If you want to see them this time of year, go out on a trail with a little bit of grass growing up on the side and look for these caterpillars climbing up and feeding on the tips of grass in the evenings. Sometimes you can see them during the day. They're a pretty bright, obvious caterpillar, but I have better luck finding them at night. So these caterpillars go off and become an adult pollinator. They are feeding in some of our edge habitats that tend to get a little bit overlooked. They're feeding on a plant that people tend to overlook, grasses. They also interact with a habitat that is a little bit challenging for people. They're living in sometimes tall grasses, in edges on trails, places that people tend to assume might be difficult to access. Maybe people are starting to notice a lot more ticks and be a little bit more aware of like tick-borne disease. Maybe people are thinking about mosquitoes and leaf litter and standing water and grasses. Anytime we have this interaction between things that feel like a threat to people and the wild insects and other animals that are using these habitats, that does present a bit of a challenge, especially for access. So when we're thinking about landscape management and how we get people outside, how we get people excited and engaged with nature, and share the idea that these animals need this really kind of rugged, chaotic landscape that might be also a habitat for ticks or also a habitat for mosquitoes. We want to think about how we can increase access without decreasing the value that these environments provide for these native insects. So I like to think of this as sort of both a do no harm or do less harm, but also a sort of a shared space idea. If we want to conserve our habitats, if we want people to be excited about nature, if we want to have more people outside and engage with insects, engage with our landscapes, we have to make sure that they feel comfortable there. And really, sometimes the only way to do that is to create human habitats that feel comfortable. So sometimes that does mean mowing certain habitats. Sometimes that means creating certain spaces that are accessible for people, but maybe not for insects like this. One thing I would encourage, if nothing else, well, there's two big things. One thing I would encourage, if nothing else, leaving space for these insects. So you don't have to mow an entire trail side. You might have to mow just space for maybe two people to walk, giving space for people to feel comfortable to be outside, as many of you may know, while also leaving some of this wild habitat where they can see and interact with these insects and know that there is value in this landscape without making it feel unapproachable to them. One of my favorite little state parks around here, Otterbrook State Park, does a really great job each year going and mowing little paths around the waterside and leaving all of this just crazy mess everywhere that people aren't really walking or using. They create a little like frisbee golf area where people can run with their dogs, and the rest of it is just left up to nature and left to regrow. The one caveat there is if we are letting nature take its course, there is still management that we have to practice. Especially here in New England, we're kind of in a little bit of a lucky zone. We have lots of invasive plants. We have plenty of invasive insects. However, we are still in a space and a time with our habitats where we can manage a lot of these invasives. So if you are out interacting with the landscape, things like invasive management, removing invasives, educating people about what an invasive looks like, those are as important as preserving native habitats, preserving native plants, and preserving native insects. So really our two big key points, not to get too into the how to manage your landscape side of things, are really make sure that you are creating access for both people and insects, leaving space for both us and them, creating these edge habitats, and also remove invasives if you do nothing else. So that's a pretty long little spiel. I think I've gone a little over my promised 45 minutes to an hour. I would love to answer a few questions. I have plenty of caterpillars behind me, so if anyone just gets really excited about seeing more caterpillars under the microscope, feel free to add just more caterpillars in the chat. and I will take a few questions here.
Okay, great. So I'm seeing questions from, that was great, Sarah. Thank you so much. I'm going to take some from the chat in order, but remember everyone, if you put your hand up on the screen, then I'll also come to you. So Joan is asking about the tent caterpillars and seeing them in black cherry trees. And Joan's question is, do all tent caterpillars leave the nest at the same time? And can we see lots of moths around the tree?
Oh, yes. Tent caterpillars have some really interesting behaviors. So if this camera decides to focus, you might see a little nest of tent caterpillars all sitting on a branch together. These are final instar or fully grown tent caterpillar, well, fully grown larvae of tent caterpillars. They still have to go off and become pupa and then adult moths. When tent caterpillars go to feed, they'll usually send out, shouldn't say send, usually a few caterpillars, maybe 2 or 3, might head out of the nest, and they're kind of the foragers. It's not necessarily a caste system in the way that social insects like some bees and some wasps might act, but they definitely do have caterpillars that go out and find food. And once they find food, they'll leave a pheromone trail attached to a little line of silk on the tree. And that pheromone trail will say, there's food this way, or maybe tent this way. And the rest of the caterpillars will slowly kind of trickle out. It does seem like, for the most part, the majority of tent caterpillars will leave the tent at a time to go off and feed following that pheromone trail. Sometimes you'll see tent caterpillars create a huge circle around a tree where that pheromone trail led to no food and then just kept circling. And then if it's not broken or the caterpillars don't drop off and leave a new trail, they'll just keep endlessly following that. We've had that happen sometimes in captivity, so that's something we have to watch for. There are plenty of tent caterpillars that will stay in the tent. This probably isn't going to be all that visible to you because it's through the silk, but do you see how there's one smaller tent caterpillar in here? Caterpillars don't necessarily all grow at the same rate, so we'll have younger, smaller tent caterpillars maybe still molting or shedding their skin inside the tents. Sometimes they will stay inside and we don't really know why. There's a lot of social caterpillar behavior that happens that isn't really well studied to the best of my knowledge. There's somewhere around here, there's a tent caterpillar book about this thick that's all about tent caterpillars. And in perusing through it, I haven't really seen all that much about exactly what their behaviors are beyond feeding and building a tent. When you look for moths for tent caterpillars, you are unlikely to see a lot of them around the tent. Their moths, like our giant silk moths, are non-feeding as adults, so they have a very short life cycle, maybe days up to about a week. The caterpillars in their final instar do tend to disperse. So as younger caterpillars all stay in this tent, as they get older, they start to wander off. Some will build cocoons inside the tent, some build cocoons further away. If you're really lucky, and you want to see the tent caterpillars, the best way to find them is to set up a bright UV light at night. You want a really high UV component and a really bright light if you can. So something like a mercury vapor bulb if you're really excited about catching moths. And kind of in the late summer is when you'll start to see these little fuzzy moths fly in. They look like a little curled up dead leaf. And those are our tent moths.
Okay, excellent. So from Carol, from the Rehoboth Land Trust, where do spicebush swallowtails tend to overwinter in their chrysalids? Are they on the sassafras and spicebush twigs or down low?
Oh, a lot of our butterflies are a little secretive. Like our tent caterpillars, butterflies can wander a pretty good distance from their host plants. In my experience and from what I've seen and read and talked with other people, it seems like caterpillars mostly don't want to become pupa on a soft surface. So a leaf or like say a monarch becoming a pupa on a milkweed plant, those are kind of dangerous spots for it. So you might look for a chrysalis lower down on the bark or the trunk of a sassafras or a spicebush tree if you have a bigger tree. More often, we tend to find them on overhangs. So if you have a rock wall nearby, looking in the crevices of rock walls, if you have a trail sign, often looking under the edges of trail signs, or if there's a no trespassing sign on a tree, often there are moths and caterpillars stuck underneath as pupa and chrysalis underneath the no trespassing sign. They kind of like these little hidden spots. That being said, if you have a year where you have a ton of swallowtail butterflies, you might be finding chrysalis absolutely everywhere. I do not have any of their chrysalis over here with me. I should, because we have plenty of them. Swallowtails also do something really fun where they have different colors depending on the texture of the surface that they're pupating on. So if the caterpillar becomes a pupa or becomes a chrysalis on a smooth surface, they tend to be green. And if they become a pupa or chrysalis on a rough surface, they tend to be brown, at least for spicebush swallowtails and pipevine swallowtails. And that may be an adaptation to having multiple generations a year. So in their first generation that is active kind of at the peak of summer, those pupa are interacting with fresh green leaves, fresh smooth stems. They might not be down in the leaf litter or in the same crevices. So they're going to stay green to camouflage with these green plants. Later on in the season, if they're interacting with more dead leaves, maybe they're in a leaf pile, maybe they're kind of tucked away in some logs somewhere, that's when we tend to see more of these brown chrysalis associated with those rougher textures. At least that's my theory on it.
So you'd mentioned about this being a tough spring. Certainly it has been in Massachusetts, sort of very cold. So a question about how has the cold winter and this cool spring impacted moths and caterpillars?
Yeah, it is interesting. I think we tend to anticipate seeing fewer moths and caterpillars in colder seasons like this. However, we are still going out. We're finding tons of caterpillars. We're finding lots of plants continuing to put out their leaves. This year, we haven't had the same kind of we haven't yet had the late season frost that has been pretty devastating the last few years. And really, a cold, consistent spring might slow things down. Things might change their seasonality a bit. But overall, it doesn't. This is anecdotal. There is absolutely no hard data to back this up. So please don't quote me on this too seriously. But over the last few years, it seems like with a consistent cold spring, things might be slowed down, things might be delayed, but it doesn't necessarily seem like it's stopping a lot of our caterpillars. It's not stopping a lot of our plants. Things are still going about their life cycles. Really, what we're seeing more impact from, again, anecdotally, are bigger temperature swings. So these really cold winters that are very dry with not a lot of insulating snow layer, or maybe not a lot of insulating leaf material underneath the snow layer, going to these very warm midwinter days. That can be pretty dangerous for insects that need that insulation because there's nothing stopping that cold and then hot from interacting with their circadian rhythm. So things like our question mark butterflies, for example, those might be depending on a series of warm days or a series of warm nights to tell them it's spring. And if that happens, say in January, and then it gets really cold again, that can be pretty damaging to their populations. Same thing in May, if we get a really, really cold snap, especially after this big warm up that's coming this week, that might really impact the number of insects that we're seeing outside. That said, it is very, very difficult to study insect populations and to collect numbers. You need a ton of information, and it is really hard to definitively say we're seeing insect decline rapidly as a result of these direct changes. So over time, we can definitely say insects seem to be declining. We're not really sure why, but it might be associated with these changes in seasonality where we have big temperature swings in seasons where it is a little bit more sensitive for them.
Okay. So a question about disinfecting some caterpillar equipment. Any suggestions for how to disinfect a wooden screen-sided caterpillar/insect rearing cage that my dad made many years ago?
Yeah, it can kind of depend on what you're interacting with. We tend to interact a little bit less with a lot of insect diseases, partially because we don't do a lot of captive rearing. So a lot of things like OE that people who raise monarchs deal with isn't really a huge concern for us.
Can you explain, sorry, Sarah, can you just explain what OE is just for the folks? Is it the Black Death one?
Yeah, I'm not super versed in what it actually is. I don't think it's a bacteria. I think it's like a paramecium or something that the caterpillars get. And it's essentially like an infection that sort of liquefies them as caterpillars. So you'll see them kind of turn black and dissolve. There's another caterpillar disease that they get, which I think is caused by, I think this one is a bacteria, that we colloquially call poopy butt or muddy butt. And it causes kind of liquidy droppings and sort of caterpillars with no appetite that are just kind of slowly declining. When we deal with insect disease, the best thing that we've found so far is high heat. There's lots of stuff online about using ammonia and using bleach and all sorts of things, using autoclaves, and that's both inaccessible for a lot of us and also pretty damaging to the ecosystem if you are spraying everything with really high concentration ammonia, and then you're going and dumping that somewhere. You either have to do that safely with a hazardous waste disposal, or you just have to know how to do that, which I certainly don't. So when I was researching this for some of our own disease issues, we ended up just buying a high heat dishwasher, and we just blast everything with not quite boiling water. We want it to be, I think, 180 degrees was what I was seeing in a lot of the research that I was reading. So honestly, if you have a kettle and you just boil some water and pour it over the wood, that might help. We also have success with drying things in direct sunlight and using UV to kind of denature some of the proteins of some of these organisms or like viruses that our caterpillars might interact with. But if you've had a wood cage for a long time and it hasn't had caterpillars in it for a bit, I wouldn't be too worried about it having something that could affect the caterpillars. It's really only if you're consistently raising caterpillars in them and consistently introducing some of these pathogens that's when I would start to think about disinfecting.
Okay. Carol was saying it's a protozoan, and I just double checked, and she's quite right.
Thank you.
Ophrysistis electro, I can't murder the Greek. I think it's Greek. It's a protozoan parasite. So, okay. Yeah. So, can I ask you about my absolute favorite caterpillar? I promised that I wouldn't hog the conversation, but I love the hickory horned devil. It's just such an incredible insect, but I've only ever seen it as a caterpillar. I think no, I've seen it once at the lab as an adult. So they are not. There's no population here anymore, right? They're captive bred always.
Not always.
Okay.
So they are. Where did my Zoom screen go? Well, oh, here we go. Hickory horned devils are native to most of North America, at least eastern North America. There are some reports of them all the way up through Maine, potentially up into Nova Scotia. For those of you who are less familiar with them, they are caterpillars about the size of a hot dog with these incredible horns coming off of their head, and they turn into a relative of the Polyphemus moth that I was showing on the screen earlier, about the size of my hand with these bright orange and yellow stripes. And historically, they wouldn't say pretty common, but they were probably about as common as maybe a Luna moth in Massachusetts. And at some point, around the 1980s, they started to disappear. And someone at some point realized, oh, hey, I haven't seen a hickory horned devil in a long time. And it turns out they are almost completely missing from our New England habitats. And we think that happened about 40 or so years ago. It seems to be associated with the spongy moth outbreak. So this is a very long and winding story with a very long and winding answer. But the spongy moths are, again, a non-native invasive caterpillar that was accidentally introduced from Europe. There was a gentleman who thought he could breed super silkworms using them. And the story goes he introduced a single gravid female, and that's where we get all of the spongy moths we now have from. And in the early 1800s, people also released a parasitic fly to try and kill off the spongy moth population, kind of using that idea of, if you have caterpillars, their insect predators can match their populations pretty quickly and bring them back down. Unfortunately, that fly is a generalist, and it feeds on over 300 of our native species here in New England, particularly our giant silk moths, like the hickory horned devil, like the Cecropia moth, like the Luna moth. It seems to really love those. So spongy moths are a pretty tough caterpillar to eat, and it had all this free food, and it just kind of overpopulated. And now we have this parasitic fly, Compsillura, going after hundreds of our native species. Around that same time that the hickory horned devil disappeared, we had a huge outbreak of the spongy moths. And during that outbreak, their non-native invasive parasitic fly also overpopulated because, again, more free food equals more predators. And that fly, we believe, likely went off and caused the local extinction or the extirpation of maybe up to a dozen or so of our native species, including the hickory horned devil, several species of Datana caterpillars, like the yellow-necked caterpillar is one that we still have, There's a couple of other really cool looking Datana, which if you ever come to a Caterpillar Lab program later in the summer, we'll definitely talk your ear off about. The hickory horn devils are kind of unique. So they are almost completely extirpated from New England. However, there is a population on Martha's Vineyard. So if you go to Martha's Vineyard, you potentially can still see a hickory horned devil caterpillar or a hickory horned devil moth. There's also some sightings on, I think, some islands off of Connecticut, but I don't know the exact location for those. If you are someone who uses iNaturalist, I believe they might be on iNaturalist, although I think the location might be obscured. That being said, it's unlikely that they'll ever be reintroduced deliberately to New England, partially because, again, it's really, really tough to work with insect populations just because of their natural population variance. We would have to reintroduce hundreds of thousands every single year for probably decades to have any impact, and even that might not work. There is some chance that, if they're moving back into Connecticut, either that parasitic fly is starting to disappear from our habitat, or they're starting to adapt and adjust their life cycles and their timing, or maybe their own internal chemistry. And maybe that's creating a situation where they can survive the fly and become kind of a resistant caterpillar. I feel like that might be a little bit of a fantasy, but there's always hope. They are pretty adaptable animals. That's the long answer.
So, I see Mussy has a question. Mussy, do you want to unmute yourself?
Personally, do you captively breed all of yours, or do you actually trap? This is a two-part question.
Yeah. We mostly trap and collect caterpillars from either our local place here in New Hampshire, or if we are going further afield, we do some collecting on site. So we tend to have caterpillars that are wild whenever possible and local whenever possible. And that is mostly because it's a lot easier to work with wild caterpillars. Then we get to release them whenever they become too much for us. If we're trying to feed them or we're noticing we might have disease issues, we don't want to release diseased caterpillars into the world, but it is a little bit easier for us to say, wow, we have too many of these. This could become a bad situation. Let's put these back out where we found them. That being said, there is some captive rearing that happens. Things like our hornworms, for example. These are one of our more common captively reared caterpillars, and they are caterpillars that we get to work with throughout the winter because they are bred as reptile food. So we get them from most pet stores, and we can just pick up a caterpillar at the store and bring it back and feed it some tomato, and you've got seasonal caterpillars. We do very, very little captive rearing and captive breeding here at the Caterpillar Lab, sometimes with giant silk moths because they're kind of easy.
Okay, perfect. I actually have a second question after that. So in that case, what type of trapping methods do you guys tend to use? I saw you had a picture of like UV light and light traps. So I'm just curious what other things you tend to use.
Absolutely. So yeah, if you want moths, a UV light trap is probably the easiest way to get a lot of moths. You don't have to have something super professional to do this. Really just switching out a porch light with a higher UV component bulb. So even just like a really kind of bright daylight bulb can work. That'll draw in some moths. You used to be able to get mercury vapor bulbs and the ballasts for them a little bit more easily. Those are like the professional setup. That is the highest UV component. That's the best wavelength for drawing in moths, and they're super, super bright. Unfortunately, it's really hard to get them now. You can sometimes get them on eBay, and they tend to be a little bit expensive. That setup, you would want like a big sheet behind the light, and the light is drawing in the moths, and the moths tend to settle on the sheet or kind of below the sheet. That works really well if you want to get a really high diversity. It's kind of directional. So if you are trying to sample, let's say, a hillside, you want to point it at the hillside, maybe not away from the hillside. You can also use high wavelength UV lights. So if you go on Amazon right now, depending on how you feel about Amazon, you can buy a UV party panel. And it's a little panel of UV lights that you can buy for like a little disco party. And you're looking for like a 395 nanometer wavelength is the one that we use. And you can point that at a white sheet, and that will also draw in some number of moths. It's not going to be as good as something like a mercury vapor bulb where you've got that bright component to pick up more moths, but you still will get some. There's all kinds of different like UV wands and all sorts of things people sell. And I would just suggest, depending on what you're looking for, just kind of experimenting. A lot of them are pretty cheap. But if you are someone who wants to do a lot of moth sampling, definitely send us an email and we can talk a little bit more about the more professional setup and how to get that. For caterpillars, I am a very long-winded talker, if you all have noticed. For caterpillars, a UV flashlight is probably the easiest way.
I have
Can you
one.
Oh, perfect. There we go.
Yeah.
Yeah, so I've got a little caterpillar that's kind of glowing bright blue-green at the top of this plant here. And in the summertime, that is the best way to find caterpillars. I'd say starting in June all the way through September, maybe even early October, you can find a huge, huge variety of caterpillars just by going out casually on a trail side or a roadside or even your own yard. You do want to make sure you don't use a regular flashlight with one of these. There are, again, the higher wavelengths are a little bit easier to use because they make the caterpillars fluoresce a little bit more brightly. You can also go out with just a regular flashlight, and your eyes are pretty good at picking up caterpillars, even if you don't really know it. Going out with just a flashlight and shining it across different plants, this time of year, blueberry is a great spot to go look. You might start to notice weird little bubbles or things hanging off the leaves, and a lot of those turn out to be caterpillars. So if you are out and you're looking at night is a great way. And kind of just trusting your instincts and letting yourself say, "Ooh, that looked weird. I'm going to go look a little bit closer."
So this has been wonderful. I could keep you here all night, but that would be really selfish. So thank you so much for giving us this view of the biodiversity and how caterpillars, their niche within that. Everyone here tonight, this is recorded, so we'll share the recording with you. If a question suddenly pops into your head, like tonight, tomorrow, please send it to us. We'll forward it to Sarah. Is that okay, Sarah? If we follow up with some questions, and thank you all for being here. And again, we're supported by members like you. Thank you so much, and also a big thank you to Freedom's Way tonight. So I'll say good night, everyone. Thank you so much for coming out.
Thank you all for joining.
Thank you, Sarah.